Hi, everybody. My name is Jess Larson. I am meshIQ's events manager. I would like to welcome everyone attending, and we really appreciate you taking the time to join us today. So today's Tech Talk topic is fully observable event mesh powered by Solace and meshIQ. Just to let you all know, this Tech Talk is the sixth in a series of Tech Talks that meshIQ will be presenting bi-weekly. At the end of this presentation, I will include links to watch past Tech Talks on demand if you missed any of them. Also, feel free to send any questions you have in the chat box throughout the presentation for the Q&A portion at the end of the webinar, and I will read them out loud. So we have two speakers today. Richard Nikula is meshIQ's Vice President of Development and Support. He is responsible for the entire development lifecycle of all meshIQ products. He runs meshIQ's global development organization and QA and is an integration and observability expert, as well as open telemetry, application, stacking specialist, and everything in between. Our other speaker today is Thomas Kanumprath, also goes by TK, who is the Vice President of Systems Engineering for Americas at Solace, where he leads a field team to solution the Solace Pub Sub Plus platform across a wide variety of industry verticals such as finance, retail, and manufacturing. He has spent over a decade of his career leading engineering teams responsible for building out globally distributed systems for real-time trading systems and credit card systems at various banks. I will now pass it over to you, TK.
All right, thanks a lot, Jess. Very excited to be talking here today with Richard and the meshIQ team. Quite excited about this partnership as well. So in today's agenda, we're just going to go over our respective companies and what they do and the platforms that they offer. We're going to then go into observability, which is a very hot topic in today's industry. And we're going to go over a few case studies, and we're going to open it up to a very exciting feature of the PubSub Plus platform, the Solace platform. We're going to also talk about how meshIQ supports that. Then we're going to close it out with some Q&A. Okay, so introduction about Solace. The way I like to describe Solace is that we are an event-driven architecture company. We've been helping various enterprises, both large and small, become more real-time. We started out in the rough and tumble world of capital markets, where you measure latency in the microseconds. We've since expanded out into many different industry verticals: IoT, manufacturing, SAP as a technology provider OEMs our solution, and we've coined very popular terms over the period, such as event mesh, event broker, and event portal. Then we are also the organizers of the EDA Summit, which is happening in a month, and of which meshIQ is a sponsor as well. Okay, so how do we help companies and enterprises become more real-time? We do that through the PubSub Plus platform. The platform consists of a variety of components, which I'll be getting into in a little bit. But in the middle, you have the event broker, which is a heart of our offering. Then on the top, you have a management plane. On the bottom, you have a number of APIs that you would use to interact with the event broker. Obviously, since we're deployed in very sensitive industries, such as financial services, we are an extremely secure platform as well. So we have authentication engines and authorization engines built out, and we support encryption by default across our connections. Okay, so talking about our event broker, it comes in a variety of form factors. On the right-hand side is a hardware appliance, and this offers customers a tremendous amount of throughput and latency, and it's typically deployed in use cases where connection scale or latency is of paramount importance. We've also virtualized the code in our hardware appliance. We created a software container out of it, and that software container you could run on your bare metal VMs or in the cloud as an AMI image, for example. Then on top of that, we also launched SaaS of our software event broker. So click button deploy of the event broker in the cloud of your choosing. It could be GCP, Azure, AWS, obviously, and we also have deployments in other clouds such as Huawei Cloud and Ali Cloud. We support a variety of messaging protocols, which you see over here. And then we also support a number of message exchange patterns. Then we have a number of features, which I'm not going to go into in detail, but a few of the ones I'd like to call out is WAN optimization and high availability and disaster recovery semantics. Now, what we're seeing in a typical enterprise is that their application topology or deployment is becoming increasingly distributed. So you may start out with a Solace event broker in your on-premises data center, and it could be a hardware appliance, it could be a software broker. The form factor doesn't really matter in this instance. And we have these enterprises on the verge or beginning to move to the cloud. So it could be public cloud, it could be a private cloud. Now, since you have this distributed topology of applications, what you require is a uniform way to event stream data from source to destination. That is where the Solace event mesh comes into play. So event mesh, you could think of it as an architectural practice or topology to link together event brokers no matter where they're deployed. So on the bottom, you could see the Solace event broker deployed in your on-premises data center. Again, it could be a hardware appliance form factor. And in the clouds, you could have our SaaS service as well. And these event brokers link together to form what is known as an event mesh. What the event mesh offers you the ability to do is, say you are a bank and you're publishing a payment event on your on-premises network through JMS, for example. That payment event will not traverse the WAN link unless a microservice, in this case AWS, comes up and expresses interest in that specific payment event. Only then will the event flow from source to destination, in this case from on-prem to AWS. The key thing here is we only send data on demand. The mesh is self-learning, so it knows where the subscriptions are required and forwards information on that way. This has significant implications. Since you're not fire hosing data everywhere, you're making effective use of your compute and your network, which at the end of the day are finite resources, especially as our customers, especially our banking customers, or anybody who's dealing with event streaming at scale, they come to realize that the public cloud loves taking your data, but when they give it back, they charge egress costs. So only sending data where it needs to go is a significant value prop and ends up saving our customers a lot of time, money, and complexity. So this event mesh works in either direction. You can see you have a Kafka cluster pushing data onto the event mesh, and that data is received from by your on-premises network, and it works in any direction, so north, south, east, west, and it's also used as a viable multi-cloud event streaming strategy. So that's event mesh, and you might imagine creating this event mesh is quite complex, and we made it super simple. So what we offer is a single pane of glass to control your event brokers no matter where they deploy and link them together. And that is our SaaS solution. So you could have an on-premises network of event brokers. You could then link it to the cloud and form this intelligent network. Then with that intelligent network, you're only routing data where it needs to go. So single pane of glass to link together your event brokers, stream data back and forth in any direction, and do it in a very smart and efficient way with high availability and disaster recovery semantics built in. So the next problem that we've aimed to solve is the ability to manage your event-driven architecture. So adopting an event-driven architecture is extremely simple. All you need is an event broker. You have a publisher and a number of publishers and a number of subscribers, and you think you may have an event-driven architecture, which is true. But as you scale that, it becomes extremely difficult to manage. So questions like who is publishing this payment event or who is publishing this IoT event becomes very complex to solve for. That's where we've introduced the event portal. The event portal is a single place where you could catalog, design, discover your event streams, and we do it independent of the event broker. So we support, for example, Solace and Kafka event brokers in various flavors today. And with that portal, you're able to point it at your existing messaging estate and get a discovery of all the event streams and have them be cataloged and for you to expose this catalog to internal lines of business as well as partners as well. Okay. We're just talking about a use case where we're deployed, and this is a top 10 global bank, and they deployed a global mesh of event brokers that span both hardware appliances as well as SaaS. And they've consolidated their previous messaging architecture into Solace. They realized a significant savings in their infrastructure costs, in certain cases, reducing their or doing a consolidation of 30 servers into one single Solace appliance or a pair of Solace appliances. And they also have extended this architecture to the cloud using our event mesh capabilities. So what it provides them, the way the customer put it to us, is that Solace provides a cloud agnostic highway to the public cloud. What that means is that they're not locked to a specific hyperscaler streaming technology. They're able to use us on-prem as well as a cloud, and through the event mesh's self-learning capabilities, save a significant amount of cost on egress as well. And then monitoring all of this with meshIQ too. That being said, I'll now pass it over to my co-speaker, Richard, to speak about meshIQ and its platform. So Richard, over to you.
All right, thanks, DK. All right, so give us a second here as I switch over. We're trying to cooperatively present today, so we'll hopefully accomplish that. So we'll go ahead and continue on. And I'll talk a little bit about meshIQ for those of you who are not familiar with us. meshIQ is an observability platform that was built for the mesh. And in fact, our name signifies that we are interested in messaging, event processing, streaming, and the hybrid cloud. We have 100+ customers across the globe. We are a leader in the monitoring and the management and administration of the mesh. And we have been recognized in a number of different categories around the mesh. What is the mesh, right? So a couple of quick words about this. And the key thing is that, sort of extending what TK was going through, we deal with the fact that there are, in fact, a lot of different technologies that have been brought to bear to solve this problem of application interoperability. And it's sort of is a historical sort of chain of events where originally there was messaging. That was a major step forward. And then event processing came along, and then streaming, and then ultimately this model where all of those exist in a hybrid cloud, both on-premise, on-cloud, multi-cloud, you name it, everybody's got a little bit of everything these days. And so being able to have visibility across all of those layers is very, very key to you. And specifically, the areas that we cover are in governance, which is basically dealing with the implementation, the configuration, being able to do secure operations against those. Introspection, which is analytics, looking at the data, tracking things through that environment. Machine learning, where we apply intelligence and real-time monitoring to the data that's coming in and being able to be proactive. And then, of course, the ability to take actions and be able to actually do things either to resolve a problem or as a direct result of some situations that are occurring. And then those are then subcategorized things that you probably recognized, areas around DevOps, diagnostics, monitoring, configuration, observability. That represents the full meshIQ solution. And much like we were just discussing, that is a very diverse set of components, and there's a lot of different stakeholders. There are developers, there's application owners, there's shared services or support teams that are responsible for managing that environment and being able to see what's going on. And they need to be able to, to see the configurations and maybe make changes to them, being able to search for things, messages across the web or, across the mesh, being able to, to see what's going on, right? So that's really where the meshIQ platform comes into play. Right? So again, a case study that we might look at would be a global bank, that's doing business. And what are their problems? Well, again, they have all this diverse middleware stack that they've had for years, right? They brought in IBM MQ at one point. They brought in Tibco EMS, maybe through an acquisition in their case. And then Kafka, because now, that was the latest and greatest. And then eventually introduced Solace, because they needed to modernize their aging applications. And so they've got all these different things that they're dealing with. The homegrown tooling, a lot of, in their case, they had built tooling, but they're not supportable because the people who wrote them are long gone. And of course, things keep changing. And now, now we got to add that to our tooling. Well, it just wasn't sustainable, right? And when they were onboarding the new applications, things were very inconsistent. So they brought in the meshIQ solution to do administration, monitoring, and automation, and that allowed them to standardize across their middleware stack to automate the application deployment and the out-of-the-box monitoring, and that, of course, led to relied applications. And a couple of quick views of how that might work, right, is if you think of a simple application, and this is much simpler than the previous version. We've got some queues sitting in MQ. We've got Kafka connecting in. We've got the Solace PubSub connector for IBM MQ involved. And those are all there. Well, if I'm an administrator and I need to look at that environment, then I need that view across the environment. So here I'm looking at my Solace environment. I'm an administrator, happen to be in this case, I'm dealing with Solace right now. But you can see at the same time, I still have MQ and Kafka and other things as well, but I have visibility into my Solace environment and all of the different components, again, across the entire mesh. So this could be, again, instances of Solace on cloud, on-premise, software versus hardware, doesn't matter. You get to see all of that in one single place within the meshIQ solution. Okay. And then similarly, if we looked at an application view, and I think this is a very interesting one, because from the application view, you actually have an application who's now got queues in MQ. He's got queues in Solace, and he's got topics in Kafka topics that are all tied together. And he's able to sit in one place and see all of those and even test those applications. So I could put a message here and see how it flows through the mesh. Does it reach the right places, and be able to, to get to the right points? And then, of course, being able to monitor those environments, being able to see what problems are occurring across all those places as well. And then ultimately to be able to observe the behavior within those applications, and looking at things like throughput and being able to spot the difference between a drop in throughput between, the normal behavior and the current behavior, right? So all of those things are really key parts of the meshIQ platform. Okay, all right. So back over to you, Thomas, to move into the next topic.
All right, thanks a lot for that overview of the platform, Richard. Now over to distributed tracing. So distributed tracing is a feature that the Solace event broker recently released as GA, and is quite excited about it. But before I jump into that, I just want to go into the reasons and the motivations of why we developed it. And let's look at that through the evolution of application architecture. So back in the day, when enterprises or people started writing applications, it was a very simple architecture, right? You had your monolith, consists of all your functionality, and it did something and potentially wrote to a data store. So this wasn't scalable. So the next thing that architects came up with is a concept of obviously microservices. So microservices take this large functionality in monolith, break it down into individual functions, and then do some action and ultimately write the result to a data store potentially. The benefit here is that obviously you get agility, because now you could upgrade these individual components or pieces of functionality and not impact the entire application stack while you do that. So this is good, but as you can see here, this is there still is a dependency or a synchronous dependency. So what happens when any of these individual microservices fail and there's still some tight coupling involved? So the next thing that people move to is event-driven architecture. It's a promise of event-driven architecture that it is truly decoupled and asynchronous processing. So you publish once, your microservice, for example, could publish, could have other microservices that subscribe. And so you could independently upgrade or change these microservices without impacting the other microservices involved with this event-driven architecture. You could also add new microservices. So the benefit of event-driven architecture is you publish once, and then your subscribers could subscribe independently, and you could spin up more as needed. Now, as we talked about, enterprises are becoming extremely distributed, both geographically within their data center topology, as well as moving to the cloud. So they've started to introduce an event mesh as well. So not only do you have to worry about event streams flowing across your data center, you have to now worry about it flowing across the WAN to other data centers and the cloud as well. So what does this look like? Just a visual is that you have these constant event streams that are flowing from source to destination, again, from on-prem to the cloud or to multiple clouds. And these events can be extremely critical. These could be million-dollar payment events, or they could be trade orders. If you don't fulfill them on time, there are potentially, dire consequences. It could be regulatory consequences, or there could be, customer experience consequences as well. And so the key thing here is, how do you manage this? Yes, you've realized the vision of decoupling your microservices, but how do you know if your microservices are performing? How do you know whether the event mesh or the event brokers are performing appropriately? And how do you trace a single payment event through this complex network that you have deployed within your enterprise? That's where distributed tracing comes into play. So we're seeing observability become increasingly important across enterprises, just again, going back to how complex their network topology is. And Gartner says that they expect by 2025, 70% of applications, in this case in the cloud, will introduce observability through the OpenTelemetry standard. And there are three pillars of observability. There's logs, metrics, and traces. And the PubSub Plus platform natively supports all three. Okay. So what exactly is distributed tracing? Well, it allows you to see when an event enters your event mesh, when it traverses a link between the event mesh, and when the consumer or microservice was able to process it. So a administrator or a business analyst could trace that singular $1 million payment event, see how long it took to process at every hop, and tie it all together. So you could do things like enforcing SLAs or figuring out which part of your application stack to re-engineer or focus on to improve the performance. And so we've implemented distributed tracing natively within the event broker, and we are the only event broker that is able to do that currently on the market. So the event broker itself will emit these traces through the OpenTelemetry standard. The benefit of doing this via an open standard is it becomes very easy for partners like meshIQ to tap into these traces. And so you could, using a collector architecture, you could forward these traces over to meshIQ and get that holistic view of your message flow from source all the way to destination. Okay, now I'll pass it back to you, Richard, to close it off.
Okay. So again, we've saw this picture, and in fact, the TK introduced the concept of OpenTelemetry. And one of the key things about OpenTelemetry is the concept of spans. And spans allow you to basically identify the pieces of work that all need to be stitched together, right? So a term that, in fact, meshIQ has been using for many years, the concept of stitching things together, is basically bringing correlators produced at the different parts of your application together in order to be able to see what's going on. So with open telemetry, you now have visibility directly into those spans from the components that are producing them. So in a perfect world where everything is managed with open telemetry, basically you then just need, as he said, a common place for which you can send all of that data and manage it, right? So that is where the meshIQ solution comes into play, because we have visibility into that entire mesh. And in fact, we have visibility into components that aren't open telemetry, right? So not everything in the world is going to comply with open telemetry. Even if we get to 70% of the new applications, there's a lot of legacy applications and a lot of things that may not be open telemetry enabled. So being able to bring all of those into a central point is key to being able to see what's going on. And then what do we need to do? Well, again, we need to take those components and be able to provide a picture, a view of that data so that you can see the behavior of that application. And again, dealing with, many, thousands or millions of application flows, being able to spot, where in that flow is the single point of failure, where is where are SLAs being missed, for example. That's a key part of being able to manage the environment, is having SLAs in place so that when something goes wrong, what does it impact, right? Not just how long does it take, but what is the impact of that behavior? And then being able to actually look at those and be able to see what is going on. And that's where, again, where a platform like meshIQ comes into play, because we have different ways of looking at it, right? So we might want to be able to see, what are the flows that are going on, how do they break down? How is the time being reported over time? Again, not just, not now, but maybe for the last day. Are we seeing changes in behavior? So we mentioned, the machine learning aspects of being able to do analytics and watch for anomalies in behavior and to determine, are the trends going in a negative direction? Do we need to be able to, to identify those, right? So that's a key part of the meshIQ platform. And then one part I want to draw your attention to is actually this upper right quadrant up here, where you'll see that actually we have values where it says euros and pounds and Japanese yens, because now one of the other things that we can get access to are metrics that the applications are producing. And those metrics can be things like dollar amounts. And if you have access to that information, then you can start using that also to make determinations about what's going on, right? I actually had one customer once ask me, can you highlight this information at 10 in the morning, because that's the time that the Japanese market closes, right? And it's like, well, gosh, I hadn't even thought of that myself. But because the banks and the things are all international, things change by time of day as to when they become important, right? So again, that's a key aspect of being able to manage this with the mesh. And that's where the meshIQ solutions come into play, with our ability to have visibility across all of the components of the application, regardless of where they run, where they are in the mesh. Okay. And I think with that, we actually have reached the Q&A portion of the presentation. So Jessica, back over to you.
Yes, thank you, Richard. So yes, we have received a couple questions. The first one, TK, can you give us a few insights and observations about how enterprises are reasoning about and using observability today?
Sure. So I'd say it's like a fairly new and upcoming train of thought, as well as a standard. It's evolving, and so we see banks in general and enterprise in general standing up observability teams. So their mandate is to figure out how to get more visibility into their application. So I was talking to a retail customer recently, and they successfully moved large portions of their flows into the cloud. And what they told us is that it's great that we're moving things into the cloud. We are event streaming into the cloud. They were using Google Pub Sub in this case. And they said that they told me that when they started, it was low volume, everything worked fine. But as they started ramping up, they would lose visibility into their orders. And so their business would come to them and say, hey, we're getting complaints from our customers that we're not fulfilling orders. Could you tell me why? And they said that essentially it's a black box. Like you push an event or you push a request into an event streaming solution. There's some black magic that happens there, and you hope it gets distributed to the microservices or the consumers or the mobile app. But a lot of times you lose that visibility. So they said that introducing distributed trace was extremely essential and important to ensure that they are able to continue to migrate to their cloud and service their customers.
Richard, did you have any thoughts or anything you wanted to add?
Sure. I think one thing and it's interesting, I would agree with TK that this is it's certainly becoming much more obvious its importance today, but it's actually always been important. I think the thing that's changed is really the complexity level, right? As you move across the mesh, the complexity increases quite a bit. Even though, if you go back when the original MQ came out and, it was one application talking to another, it wasn't that complex. I mean, but it still was something you had to deal with. One of those applications might be on a mainframe and the other one might be on a distributed system. But that quickly became much more complex, right? You had multiple applications, you had brokers, and as you added new technologies and acquisitions and all the things that happened, it just got more and more complex. And now we've reached a point where everyone realizes that the complexity is just something that has to be dealt with, right? And if you don't, then you have chaos. And so I think that's really the key today, is everyone is sort of understands now the importance of why this is important, not just that, it is something, well, maybe we'll think about it.
Mm-hmm. Okay, well, we received one more question. TK, what do you think is the biggest challenge facing organizations from instrumenting end-to-end observability across their tech stack?
Yeah, so as previously mentioned, the open telemetry standard is evolving, so that's number one. And also, when you add observability to your application stack, there is an impact, right? Nothing comes for free. So like, especially in any high volume use cases, you have to be high volume, low latency use cases, you have to be mindful of what the impact of tracing is. So Solace took a very proactive stance in helping customers along. And so we are able to dynamically turn on and off our tracing capabilities. So you're not tracing everything all the time. You could perhaps decide during a certain point of the day that you want to trace certain flows, or when there's a production problem, you could start turning it on to get to a better understanding of root cause quicker. And so that is, I'd say, point number one, just understanding the impact of turning on tracing. Second thing is instrumenting your applications to be able to have this tracing capability. So again, the benefit of the way Solace has introduced distributed tracing is that since it's from the broker's perspective, your publishers and subscribers don't have to add anything. That trace comes for free. If you do want to do more holistic end-to-end tracing, then you do have to instrument your publishers to have what Richard described previously, the span and the traces. But the benefit of the Solace broker is that if you don't instrument your publishers, you don't instrument your subscribers, you still get the tracing functionality since it's emitted from the broker. That's it.
Richard, what do you think is the biggest challenge?
Well, oddly enough, I think and it was, I'll go with the point that he just raised, is that it's very difficult to get this. You need to be thinking about this when the applications are originally developed. To really understand the behavior of applications does require some investment from the applications to make that happen. But it's rare that the application teams have the time or even the thoughts to do that, right? So when they're originally developing their applications, saying, gosh, worry about the fact down the road when this happens and give us the data we'll need to solve it, isn't something that's on the top of their minds. And so, while it's a key part of the requirement, it is very hard to do. And so again, solutions that at least enable that help. But again, it really does get down to you've got to have people thinking about being, what's going to happen when we're in production. And usually that's the last thing, and they have deadlines and it doesn't impact their deadline. So they go with whatever's the quickest. So big challenge is getting people to really understand that this is important.
Well, it looks like we have answered all of your questions. We will have this Tech Talk available on demand, posted on the meshIQ website following this call at www.meshiq.com. Also, please note this webinar is part of a series of Tech Talks. We rotate the topics and really try to focus on different middleware technologies. We would love to have you join again, so please be on the lookout for our next upcoming webinar on May 16th at 11 a.m. Eastern, live from Kafka Summit London. I wanted to thank TK and Solace for partnering with us on this Tech Talk, and thank you to all who joined in today. Have a great rest of your day.